Hi everybody, this is Miss Hamilton. So we're on day 2 of Quadratics Unit 2. So we're going to start with a little bit of review of simplifying. So just remembering from yesterday's notes, we start with the coefficients first. So negative 3 times 4. And we end up getting a value of negative 12. Then we focus on the variables. So x squared times x becomes x3, and then y, because it's not multiplying by anything else, stays as y. Looking at the next question, we're looking for like terms. So there's only two terms that are alike in this situation, negative 8xy and negative 2xy. So we can leave everything else the same in the equation, and then we can work on collecting the like terms. So negative 8xy minus 2xy gives us a value of negative 10xy. The last one is more of a distributive property type of question where we're going to be multiplying in. So just remembering your order of operations here. So we're going to be multiplying in the value. So let's start with x times 1/4. So we still get 1/4 x squared, and then x times negative 9 is negative 9x. So similar problem to question C. Question D starts with distributive property as well. Okay. So let's focus on the first part where we're going to multiply 6x into the brackets. So 6x times x becomes 6x squared. And then 6x times negative 1 becomes negative 6. Moving on to the second part of the equation, just note that it's negative 4. You always look to the left of the coefficient or the value. So we multiply, we get negative 4x and positive 4. So in this equation, you're going to notice right away that we actually have two like terms. So we have negative 6x and negative 4x. So we can combine those like terms because they have the same exponent value. We get negative 10x plus 4. Which, if you look at that question, you'll kind of understand that that is standard form of a quadratic equation. So we will be working more with that stuff. The last question, you're going to use FOIL to solve. Okay, so we start with the first. We get 4x squared. We start with the outside. We get 6x. Then we go into the insides. And then we do the last. Okay. Again, you'll notice that we have like terms here, but positive 6x minus 6x actually eliminates. And we're left with a final answer of 4x squared minus 9, and we call that a difference of squares question, which we'll be explaining later on in this unit next week. So again, that's a little bit of review from yesterday's lesson. What we're going to do is we're actually going to take this simplifying method and apply it into shapes and more real life situations. So the new work. We're going to be looking at perimeter and area, so it's important that if you're looking at a figure that you know the formulas for this. Okay, and they are basic formulas and I'd give them to you. So they would like to find the perimeter and the area of each of the ones. So let's start with the perimeter of the square, or the rectangle I should say. So we know that perimeter is adding up all the sides. So if we want to, we know we have 2 of x minus 5 sides, plus we know we have 2 of the 2x plus 3. And now if you look above, that question looks very similar to question D from the warm-up. So what we start with is distributive property to find the perimeter. So we get 2x minus 10. And then we would also do the same to the other side. We get plus 4x plus 6. And just like you notice, there is some like terms here. Okay? So we have the 2x and the 4x. If we add those together, we get 6x. And then if we do the negative 10 and the positive 6, we get negative 4. And that would leave us with our final answer of the perimeter of that shape. Now, area of a rectangle is represented by length times width. Well, we have the length and we have the width. So we can actually plug in those values to solve. And now, this isn't new. We know how to solve with brackets like this. Again, we would FOIL. So we start with the first. We get 2x squared. The outsides, we get negative 10x. The insides, 3x. And then the last, negative 15. One last step would be to collect the like terms. So negative 10x plus 3x. We'll rewrite it out as 2x squared minus 7x minus 15. So in this above, we have found the perimeter and the area. Let's try this with another shape. Let's try it with a triangle. Okay. So starting with the perimeter, we know the perimeter would be adding up all the different sides here. So that's exactly what we'll do. We'll do 6x minus 2 plus 3x plus 2, and then plus x plus 2. And now it's about collecting the like terms. So if I want to, I'm just going to underline 6x, positive 3x, positive x are like terms. With that, we get 6 plus 3 plus x, we would get 10x. And then negative 2 plus 2 plus 2 would leave us with a value of plus 2 as our final answer. Okay. If we wanted to find area, the formula for a triangle is base times height divided by 2. So we have the base and we have the height. So what we can do is plug those in. We go base x plus 2, okay, times 6x minus 2, all over 2. So we start with FOIL on the top, and we get 6x squared, okay, minus 2x plus 12x minus 4, and still all of that is over 2. We can collect on the top 6x squared plus 10x minus 4, all over 2. And now what we can do is we can divide everything in this equation by 2. So if we do that, 6x squared divided by 2 becomes 3x squared. Positive 10x divided by 2 becomes positive 5x. And negative 4 divided by 2 becomes negative 2. So we've been able to find the area of the triangle and the perimeter of the triangle just on using our basic knowledge of the formulas for perimeter and area, and using our simplifying and collecting like term skills. Let's do another one that is considered in a word problem. So what I would recommend is always writing and drawing out the image. So you have a square, and they're saying the square has a side length of 5x minus 1. And we know that a square has all equal sides. So if we want to, we know that perimeter would be 4 sides of 5x minus 1. And we do distributive property. So we get 20x minus 4. Area is length times width, and in this situation it would be 5x minus 1 times 5x minus 1. So again, we're going to use FOIL. So we get 25x squared minus 5x minus 5x plus 1. Not quite done that, so finishing it off, we're going to collect the like terms here. Okay. So we get negative 25x squared minus 10x plus 1. So again, we found the area and the perimeter given the information. We're going to do a couple more examples to get us through. So, a rectangle has a length of x plus 3 units and a width of x minus 4 units. Determine the increase in perimeter if the length was increased by x plus 1. Okay. So what if the length was increased by x plus 1? So what we're going to be looking at is the perimeter. And we know that the perimeter in this situation would be 2. Let's draw it out first, actually, so you can see why it would be 2. Because we have a figure, x plus 3, x minus 4. Okay, and we know that we have equal sides depending on what we're looking at. So we're going to do the original one where we're looking at 2x plus 3. Okay. And then plus 2 sides of x minus 4. We start with distributive property into the brackets. We get 2x plus 6 plus 2x minus 8. We collect those like terms, and we get 4x minus 2. Okay. So that's the original perimeter. What they're saying in this situation is, what if we take x plus 1 and add it to the original length of x plus 3? So let's go x plus 3 plus x plus 1. If we collect the like terms, we get 2x plus 4. So that is the new length. So we're actually going to do the exact same thing as we did before, just with our new length. So we're going to go perimeter equals 2 times 2x plus 4 plus 2 times x minus 4. Again, distributive property here. We would multiply in, so 4x plus 16 plus 2x minus 8. The perimeter equals 6x plus 8. So if you wanted to look at the difference, you could between the two formulas. Okay? Here's the difference between them. We can also use the information to solve for 3D figures. Okay? So if we want to determine the surface area and the volume. So the surface area is the harder one, so let's start with the volume. Okay? Volume of a rectangular prism equals length times width times height, which we have all three. So we would go length of 2x plus 1 times the width of x minus 1 times the height. So again, we start with FOIL here. So we would FOIL. We get 2x squared. Okay. Minus 2x plus x minus 1. You would put that in brackets because eventually you're going to multiply that other x in. Collect the like terms in the brackets, so we get 2x squared minus x minus 1. And then now you're going to multiply everything in the brackets by x. So we end up getting 2x3 minus x squared minus x as our final answer for the volume. Surface area is a little bit different. So of this side, you have 4 of that side. So if we want to, for surface area, we're going to be looking at 2 ways to do it. So we're going to go, we have 4 times, in the brackets, the 2x plus 1 times x minus 1. And then we would add that to the 2 sides of the x minus 1 times x. Okay? So this represents the 4 sides, this represents the 2 sides. And you could even break it down further if you want to, whatever makes sense for you. But we're going to start with inside the brackets. So we would start with FOIL here. So we get 2x squared minus 2x plus x minus 1. Okay. Doing the other side now, we would start in the brackets. So keeping that outside 2 there, we have x squared minus x. Now we can apply distributive property into the brackets. So where we're going to multiply the 4 into every term. So we're going to get 8x squared minus 8x plus 4x minus 4. And then doing the other side, we multiply in the 2, we get plus 2x squared minus 2x. Now comes the easy part. I'm just looking at the like terms. So let's break this down. We have 8x squared and positive 2x squared. So we can combine those to give you a total of 10x squared. The next one would be negative 8x, positive 4x, negative 2x. So negative 8 plus 4 is negative 4. Negative 4 subtract negative 2 is negative 6x. And then by process of elimination, you're left with negative 4 as your final answer. So we've actually been able to solve for the surface area of a 3D figure. So that is the lesson for today. You're going to get an opportunity to work on this right now in class. So your homework is going to be page 5 and 6. So that is what you're working on for the rest.